Alright, so some redox reactions we saw are simple, some are considerably more difficult. So something like this, you have ethanol, that's the CH3, CH2OH, can be oxidized with the dichromate ion, that's Cr2O72 negative. This will make ethanoic acid and chromium 3. Now, I'm going to give you some steps in order to help balance this. I would encourage you to pause the video when they come on the screen, write them down, then continue watching the video. Alright, the steps are you're going to want to split the reaction into its oxidation reduction half reactions, balance all non-oxygen and hydrogen, balance the oxygens by adding water molecules, balance the hydrogen by adding H plus ions, balance the charge with electrons, and then combining them. So I'm going to show you how this all works. So if you're given a reaction and you're not sure about what's oxidizing and reduced, you're actually going to have to go through and assign all the oxidation states to determine what the oxidation and reduction half reactions are. So for example here I'm going to start with the dichromate ion. I know that the 7 oxygens each are -2, so that would make -14. The overall charge on the ion then was -2, which means the 2 chromiums have to bring a total of +12, so each of the chromiums are +6. Chromium, that's on the reactant side, becomes +3 on the product side, so chromium 6 is reduced to chromium 3. I know that carbon is oxidized, but I'm not sure to what degree. So I can go through and assign all the oxidation numbers using the rules that we developed. I can see that carbon starts as -2 and it ends as 0. Alright, if I go through and assign all the oxidation states there. Alright, just remember that the charge on a polyatomic ion has to equal the sum of the oxidation numbers, and the charge on a molecule is 0, so the oxidation numbers must add up to 0. So I'm going to split this up, and I'm going to look at the reduction half reaction first. So this will be the conversion of chromium 6 into chromium 3. So I write the entire dichromate to negative ion, and then I write the chromium 3 product on the other side. So the first step, balance all non-hydrogen and oxygen. I need to put a 2 in front of the 2 chromiums. I need 7 waters to bring 7 oxygens to account for the 7 oxygens in O7, or Cr2O7. That requires 14 H pluses to balance the 14 hydrogens. The total charge on the left-hand side is +12. Okay, the total charge showing on the right-hand side is +6. Now, the final step is to add electrons. Remember, electrons carry units of negative charge, so they bring positive charge down, they make them more negative. So I need to add the electrons to the side with the more positive charge. Now both sides of the equation have a total charge of +6. Alright, this is going to take a few times watching. You're going to want to write the entire example out. Alright, and please make sure you do the practice questions on this. Alright, oxidation half reaction. Alright, so this is the other component. I'm going to take the ethanol, that's the CH3CH2OH. That becomes ethanoic acid, which is CH3COOH. Apply the same rules. Balance all non-hydrogen and oxygen. There's only carbons. There's 2 carbons on either side. Balance the oxygen. There's 2 oxygens on the right. There originally was 1 on the left, so I add a water molecule to the left-hand side. This is going to see me require, I'm going to need 4 hydrogen ions added to the right, and then to balance the charge, I'm going to also need to add 4 electrons to the right-hand side. Notice that the electrons were added to opposite sides in the reduction and oxidation half reactions. Right? No electrons will appear in the final solution to this problem, so that's an important check to make sure that they're on the reactant side in one and the product side in the other. Now I can't combine these equations directly because the number of electrons is wrong. So if I see 6 electrons and 4 electrons, right, I can combine these, and if I have 12 electrons on either side, the equation, I can add the 2 and my electrons will disappear. So I'm going to multiply the first equation by 2, I'm going to multiply the second equation by 3. Okay, you can see this here, so multiply every coefficient by 2 for the reduction reaction in this case, and 3 for the oxidation reaction. right? And then what I'm going to do is I'm actually going to write out all of the terms and I'm going to add them essentially. So we have two Cr2O72 negatives. We have 28 hydrogen ions. We have 12 electrons. We also on the reactant side have 3 ethanols. We have 3 water molecules. On the product side, I have now 4 chromium 3+. I have 14 water molecules. I have 3 ethanoic acids, 12 hydrogens, and 12 electrons. At this point, collect like terms, if you will. Right? There's 12 electrons on either side on the reactants and product side, so effectively you could say they cancel, they add to 0. All right, I'm going to take out the 12 hydrogens from the product side, or the 12 hydrogen ions. That'll reduce the 28 on the reactant side down to 16. 3 water molecules don't need to be on the reactant side. I'll just take 3 off the product side for a total of 11. I'm going to rewrite my final equation now without those, or after having collected those like terms. You can see that I have 2 dichromate ions, 16 hydrogen ions, 3 ethanols will produce 4 chromium 3s, 11 waters, 3 ethanoic acids. It's extremely important that you put the states in. Everything here is dissolved in water because this is acidic solution. Redox reactions require either acidic or basic solutions to be balanced and to work. All right, you are responsible for acidic solution, right? Please make sure that you include all those state symbols as well.